Okay, welcome to part 2. I'm going to back up just a little bit so we can get those who just are watching this one in with us. We're doing finding the area of a regular polygon. It has to be regular for this to work. But basically we want to do this. We want to find some angles. We want to use some trigonometry to find some measurements in this triangle. And then we want to find the area of the triangle and multiply it by the number of triangles. And we will have the area. So 5 big steps. Now, when I look at this one, I divided 360 by 5 because that's the number size, and that gave me the central angle of 72. I then subtracted from 180, and I got that it was 108, so I knew each of these had to be half of that, or 54. I've added this number so that we can find the area, because you do have to have some information. And we're going to go ahead and continue on here. This is just that lower triangle, okay? Because if sometimes drawing it by itself makes it a little easier to focus on what we're doing. Now, we need to drop an altitude down, and because it's an isosceles triangle, and always will be, that means that we will be able to know that whatever happens here, that these two pieces right here are bisected, and so they'll be equal. And this will be the new height. Now on this one we have a problem. We don't know to find the area of a triangle, we've got to know the base and the height. And we've got two different triangles. We've got a big one, and we've got one or two smaller ones that happen to be identical. We're going to focus just on this one right now and use trigonometry to find its values. Now, if we're going to do that, we've got to pick an angle. And if I look here, this was 72. This is the one I really like the way one of you on your papers did this, because I actually think this is probably a better angle to use. I'm going to split this up, and I know it's going to be equal, so I'm going to put my two equal angles there, and I'm just going to use this triangle right here. So I've got a 36, 54, 90 triangle, and I need to find the height and the base. Remember, in trigonometry we label our sides. This is going to be the hypotenuse. For this angle, this is going to be the opposite, and this is going to be the adjacent. And I'm not going to go into why at this point, other than that you can see the 8.1.2 videos to kind of get a review on trigonometry if you need that. Okay, so now that I have that, I need to pick my formula. I'm going to use some letters here just to keep track of this. I'm going to let this be B for base, and I'm not going to use H for height, but I'm going to let this be A, so we'll know what we're keeping track of. Okay, so here we go. Okay, really fast. Okay, if I'm doing this fast, I want to find the base first. And so let's see, that's going to be we know the hypotenuse, we want to know the opposite, that is sine. So the sine of 54, for one, will equal the opposite, B, over the hypotenuse. I'm going to cross multiply, and I'm going to get B equals 7 times the sine of 54, and I'm going to do it straight in the calculator. 7 times the sine of 54 should equal about 5.66. Let me check my mode because I forgot to check that. Yeah, I'm in degree mode, so I'm in good shape. Okay, so I know now that this base measurement here is 5.66. That is from here to there. Okay, now I need to find the height. And let's go ahead and do that. And let's see. It's going to be the adjacent and the hypotenuse I'm going to use this time. That's cosine. The cosine of 54 degrees will equal the adjacent over the hypotenuse. And that's going to give me A equals, or is about, 7 times the cosine of 54. So I'm going to do that here. 7 times the cosine of 54 is about 4.11. Okay, so I now know the height is about 4.11. I'm now ready to find the Now ready to find the area of this triangle. Area of all triangles is 1/2 base times height. And I'm going to find it for this whole big triangle. Couple of things I know. I know that I'm going to do 1/2. The base is 5.66, but this is also 5.66. So let's just see really quick. 5.66 times 2 is 11.32. So 11.32. And the height is 4.11. Plug it in the calculator. 0.5 times 11.32 times 4.11 gives me, let's see, whoa, it doesn't give me 54, it gives me 23.26. 23.26. So that is the area of one of these triangles. So let's bring this back. Wait, I'll let you see all the calculations for one moment. Okay, we'll bring this back. And so what we know is that the area of this triangle, keep track of what you're doing. Because we know the area of this triangle. That's what we just found. Now, how many of these triangles are there in this shape? 1, 2, 3, 4, 5. So if I take 23.26 and multiply it times 5, you get 116.3. Now that's the whole shape, okay? If I wanted to find just like 2 out of 5, I would just multiply that by 2. If I wanted to find 3 out of 5, I'd multiply this number right here by 3. So I can find parts of the original once I know that smaller, how much that first triangle is. Okay, now let's look at the problems that you have in the book, not the book, in the lesson. And I thought I had them here. Here they are. Okay. Okay, here we go. Not much time, but I'll make it happen. The perimeter of a regular polygon is 63 feet. So perimeter equals 63. The exterior angle, so I know, let's see, I'm going to draw me a little picture to help me realize this. This is the interior angle here. The exterior angle is 40 degrees. Find the length of each side. Okay, if this is the exterior angle, I know the interior angle is going to be 140 degrees. The picture helped me realize that. Okay, now, that may or may not help me. Oh, I know what I'm going to do. This angle right here, the exterior angle, I can find the number of sides by doing 360 divided by 40, and that's going to equal 9. So I know that I have 9 sides. They're all the same length, so 63 divided by 9 will equal, should equal 7. So this is a 7 gon. Okay? Remember the formula, it's the same as the central angle. 360 divided by the number of sides will give you the exterior angle, or the central angle. 360 divided by the central angle or exterior angle will give you the number of sides. Okay, number 2. Okay, number 2 says a regular polygon has an interior angle of 171 degrees. I'm going to draw this here. This is just a rough representation, 171 degrees. And it wants to know how many sides it has. Well, I'm going to find the exterior angle as 9 degrees. Okay, and so I'm going to take 360 and divide it by 9, and it'll tell me how many sides it has. It has 40. So this will have 40 sides. Same as before. 360 divided by the number, the angle, the exterior angle or the central angle will give me the number of sides. Okay, and oh, they want to know what the sum of the angles of the polygon would be. Well, I know that the inside's 171, so I'm going to do 171 times 9, and that will give me the sum of the interior angles. 171 times 9, and that's 1,539, 1,539. And let's see, you can see that there. Okay, so that is now done. Good luck.